25BB, we are going to start learning about proportional relationships today and figure out if they exist in a table or not, and then what the constant of proportionality is if it is a proportional relationship. So we're going to explain in words how to figure out if it is a proportional relationship or not. Okay? Okay, so background knowledge is solving proportions. We've been working with this for all week, right? Finding the multiplier and then using it to find the variable value. Yes? You know how to do this, yes? Okay, so first thing on your notes is vocabulary. Proportional relationship. This is if the multipliers are a constant. If they're all the same number, then the relationship is proportional. Please fill in the blank in the box on your notes. For example, if my multiplier was 1/2 and another multiplier was 2/4, are those the same number or not? They're the same number, right? 2/4 reduces to 1/2. 3/6 is still the same number. They all reduce to 1/2. So these are all the same multipliers, constant. So it leads to a proportional relationship, and you're going to fill in on your notes why. It's because all constant multipliers are equivalent. If they're all different, like 2/3, 3/4, 5/6, this does not lead to a proportional relationship because the multipliers are all different. Number one, we have this table. We want to find the multipliers. This represents 4 measurements of dirt being dug out and how long in hours it took. So 3 times what is 15? Okay, 4 times what is 20? 8 times what is 40? 9 times what is 45? So are they all the same multiplier?
Yes.
So it means that's constant. So your constant multiplier is 5. And if all the constant multipliers are equivalent, that means this table represents a proportional relationship. Okay? Since all the constant multipliers are the same, this is a proportional relationship. A little bit under number 1, there's a box for you to fill in the blanks. The constant multiplier is just what we've been calling it. It's really called the constant of proportionality. So we're going to start calling it that when we're talking about proportional relationships. So instead of just multiplier, we're going to say constant of proportionality. Fill in the blanks. So back to number 1. Oh, and K is the variable we use when we talk about constant. Instead of writing out those 3 really long words, we just say K. I know it doesn't start with K, but that's just what we use. Okay, so back to number 1. If the constant multiplier is 5, what's the constant of proportionality? It'll be K equals 5. That's what you're going to write. K equals 5. And then back down under number 1, there's another box. If a table has a proportional relationship, that constant multiplier also represents unit rate. It's the same number. The only difference is unit rate has to have what at the end? A label. Very good. So back to number 1, our unit rate is still going to be 5, but it's 5 what? Good. Yards per hour. You must have both labels. Yards per hour. Okay? So in your homework, I'm just going to ask for K equals and unit rate equals. Constant multiplier, this is just what we are practicing with. It's not really called that. It's called K equals whatever. Constant of proportionality. Okay? Number 2. 2 times what is 120? Good. 60. This represents how tall this bamboo plant is growing and how long in days it took. 3 times what is 180? 6 times what is 360? Are they all the same multiplier? So that means it's constant. And if we have a constant of proportionality, that means our table has a proportional relationship. So the constant multiplier is 60. This is just what we know. But it's really called the constant of proportionality. And how are you going to write that? K equals 60. And then what will the unit rate be? Mm-hmm. 60, how tall it's growing. Centimeters per day. And since all of the multipliers are constant, it's constantly the 60 coming up, right? That means this table represents a proportional relationship. Okay? You go ahead and do number 3. 2 times what is 6? 5 times what is 15? 6 times what is 18? 9 times what is 36? Ah, very nice. Are they all the same?
No.
They're not all the same. So we don't have a constant multiplier. We just have a bunch of different multipliers. And we don't have a constant of proportionality because if they're not all the same, this is not a proportional relationship. So there is no constant of proportionality. So how do you know? You would say, no, it's not proportional, so no, comma. Multipliers are not equivalent. Okay, that's how you would answer it on your homework. Let's look at number 4. The table is now horizontal, so I just need you to be careful of what numbers you're multiplying. So it's not 4 times what is 7 anymore. Those are both hours. We're still comparing hours to miles, so 4 times what is 140? 35. 7 times what is 245? Also 35. Do we have constant multipliers? Yes, they're both 35. That means this is a what kind of relationship? Proportional relationship. So we have a constant of proportionality, which would be what? Good. K equals 35. What would the unit rate look like?
35.
Good. 35 miles per hour. So yes, they look like they all have the same answer, but the difference here is I know you're talking about constant and that this is a proportional relationship if you tell me K equals. I know that this is a unit rate if you have the label. If you just tell me 35, that just tells me what you're multiplying by. It doesn't tell me enough information. Okay? If you tell me that K equals something, that means that everything was 35. Make sense? All right, go ahead and do number 5. This is how far a person is going in how many seconds on a bicycle. 2 times 5 is 10. 7 times what is 35? 5. And then 9 times what is 54?
6.
Are they the same thing?
No.
Nope. So do we have a constant of proportionality?
No.
How come?
Because multipliers.
Multipliers are different, so it's not a proportional relationship. And since it's not a proportional relationship, there's no constant of proportionality. Make sense? So in your homework for this kind of problem, you would say no, comma, multipliers are not equivalent. Mm-hmm.
Can we say on the constant?
Go ahead and use equivalent. Or the same is also okay. All right. Number 6. This is going into fractional multipliers, which is what we've been practicing. Those are all whole numbers, easy stuff, right? So here, back to vertical tables, because those are a little bit easier to look at. 3 times what equals 1?
3.
We want to cross the 3 out, and 1 is the answer, so it'll be 1/3. 6 times what equals 2? It'll be 2 over 6, which reduces to 1/3. Don't say 3, that's because you're dividing. There, your K would be wrong. So remember yesterday I said you need to start reducing your multiplier? This is why. I want them all to be 1/3, but if you don't reduce it, it's harder to tell. So this was 2/6, but that's really 1/3. 12 times what equals 4? It will be 4 over 12, which reduces to 1/3. So far so good. Last one. 21 times what is 7? 7 over 21, which is also 1/3. Do we have a proportional relationship?
Yes.
How do you know?
Because all the multipliers are the same.
Good. The multipliers were all 1/3. That means K equals 1/3. Unit rate equals 1/3 what? How much dirt is he digging out per hour?
1/3 yards of dirt.
1/3 yards per hour. And you told me it's proportional because multipliers are equivalent. They're all the same number. Good? You do 7, 8, and 9. Let's look at number 7. 3 times what is 2? 2/3. Good. And that is already reduced. 12 times what is 9? 9 over 12, which reduces to what? 3/4. So already we know it's not proportional, right? So you don't even have to do the last one, but I'm going to do it anyway. 30 times what is 20 will be 20 over 30, which reduces to 2/3. So not all of them are 2/3. One of them is not, which is not good enough, right? We need all of them. So since the multipliers are not equivalent, this is not a proportional relationship. So I can't answer the unit rate question. I can't answer the constant of proportionality question. There are none. So for that part, you can either write none or cross it out. Don't put 0 because a constant can be 0. Number 8. It's not times 5. I saw a lot of people write times 5. 15 times what is 3? 1/5. 3 over 15 is 1/5. 25 times what is 5? 5 over 25, which is 1/5. Are they the same number?
Yes.
Yes. So is it a proportional relationship?
Yes.
So I can answer all these questions. Constant of proportionality is what? K equals 1/5. Unit rate is
Miles per hour.
good. 1/5 miles per hour. Is it proportional? Yes, comma, multipliers are equivalent. Or multipliers are the same. Last one. 3 times what is 4? 4/3. 6 times what is 8? 8/6, which is 4/3. 12 times what is 13? 13 over 12, which I can't reduce because 13 is prime. And then the last one would be 28 over 21, which is 4/3. Are they all the same?
No.
So I don't have a constant. I don't have a proportional relationship, so I can't answer any of the other questions. No, comma, multipliers are not equivalent. There is no constant of proportionality. I cannot find a unit rate. Any questions? Raise your hand if this was easy. Awesome. Just make sure you label it and that you are using the correct numbers in the table, okay? Number 1s, would you please share what you learned today? Ready? Share.